It's going to turn out to be extremely useful to be able to put our matrices into a particular form that we call echelon form. In order to do the operations that we're going to learn in a little while here, we're not quite ready for that yet, but in order to do those operations, it's often very useful to have our matrices in echelon form, and there's more than one kind of echelon form. Before we start talking about that, though, let's talk a little bit about some vocabulary. A row of a matrix is called a zero row if all it has in it is zeros. It contains only zeros. So this 6 by 4 matrix has a zero row. This row right here contains only zeros. That's all that means, is a row that contains only zeros. A non-zero row is a row that contains at least one non-zero entry. So there's only one zero row in this matrix, but there are, 5 non-zero rows. The first row is a non-zero row because it contains at least one non-zero entry. It actually contains 4, but it doesn't matter how many it contains as long as it contains at least one. Row 3 contains more than one. Row 4, row 5. Now row 5 has a 0 entry in it, but that's okay as long as it contains at least one non-zero entry. And row 6 actually also does too. It contains exactly one non-zero entry, so it is also a non-zero row. So a non-zero row is a row that contains at least one non-zero entry. Similarly, a non-zero column is a column that contains at least one non-zero entry. Every column in this matrix is a non-zero column because there are no zero columns. We don't really talk about zero columns, but a non-zero column contains at least one non-zero entry in the column. And for this particular matrix anyway, that's true of every column. Now, one more term here, the leading entry of a row is just the first number in that row that's not 0. Okay, so the leading entry in row 1 is 3. The leading entry in row 3 is also 3, coincidentally. In row 4, it's 4. In row 5, it's 9. In row 6, the leading entry is 6 because there's a 0 in front of it, right? So the leading entry in row 6 is the number 6. Again, that's a coincidence. Okay, the first non-zero entry in a row. Of course, that means starting from the left. Some of our world languages start reading from the right, so it's important to make the distinction or make the observation that when we talk about a leading entry, we mean the first one from the left, the first non-zero entry from the left. Of course, row 2 here has no leading entry because there are no non-zero entries, right? There is no non-zero entry to be the first one from the left. So there's no leading entry. Okay, now we're going to talk about what it means to be in echelon form. And essentially all that it means is that the rows of your matrix are organized in such a way that the row with the earliest leading entry is highest in the matrix. And the row with the last possible leading entry is lowest in the matrix, and the others are similarly ranked. Okay, so for the example matrix I've written down here at the bottom of the screen, this is in echelon form because the leading entry of the first row is first, the leading entry of the second row is second, and basically you can see the leading entry of each row moves further and further to the right. This is the same matrix, but in a different order. My row 4 is in the same place, but my row 1 in the original matrix is now in row 3. Row 2 is still row 2, and row 3 is row 1. And so this matrix, the second one I've written down here, is not in echelon form, but I can put it in echelon form because of the property that says I can rearrange the rows of my matrix. So I'm going to erase all these arrows in between here. These matrices are actually effectively the same matrix because with the property or the operation that I'm allowed to change the rows around, all I need to do is take row 1 and switch it with row 3, and row 3 and switch it into the position of row 1, and it will be in echelon form. This new matrix down here is also in echelon form. There are some things missing in this one, but row 1 has a non-zero entry as it's in its first position. The row under that has its first non-zero entry over here in column 4, position 4, and the third row has one in position 5. And so there's no row here that has a non-zero entry a leading entry in position 2 or in column 2. But that's okay. All that matters is that as the rows go down, the leading entry moves to the right. That's what we call echelon form. Remember that if a matrix is not in echelon form, then you can put it in echelon form simply by rearranging the rows, assuming that it can be put into echelon form. Some matrices, at least in their when you first see them, can't be put into echelon form. So by way of example, I could write a matrix, let's just do a small one here, 3, 1, 2, 2, 1, 6, 0, 1, 1. This matrix cannot be put in echelon form in its current state. We can do some things to get it there, but at the moment we're just talking about changing rows. I don't have a row with 2 leading zeros and then a third leading term, a third leading entry. So I can't put this into echelon form just by changing the order of the rows. Okay, we're going to look at some other things that we can do to put it into echelon form, but for now, we'll just leave it at that. In our next video, we're going to talk about something called reduced row echelon form.